Math 6, Quarter 4, Week 8, Melc-Based. Let's learn about simple predictions of events with problem solving. This is from Learner's Packet Lip. Hello kids, it's me, Teacher Frel. Don't forget to subscribe, like, and share, and hit the notification bell for the latest video. You can also follow my Facebook page, Teacher Frel TV. For today's lesson in Math 6, we will discuss about simple predictions of events with problem solving. This is our last lesson for Quarter 4. For most essential learning competencies, make simple predictions of events based on the results of experiments, and solves routine and non-routine problems involving experimental and theoretical probability. Hi everyone! This will be the last lesson for the fourth quarter. Hope you are all still eager to learn more. Do you know how effective COVID vaccines are? According to WHO or World Health Organization, Pfizer-BioNTech vaccine against COVID-19 has an efficacy of 95% against symptomatic SARS-CoV-2 infection. Does it mean that getting a vaccine will save you from the virus? To answer the question, you need to know the concept of probability. According to the data above, the effectiveness of Pfizer-BioNTech vaccine is 95%. Using a number line from 0 to 1, we locate 95%. Based on the number line, we can say that if a person was vaccinated with Pfizer-BioNTech, that person will certainly not to suffer against severe COVID-19 because the number is closer to 1 or 100%. The chance that something will happen is called probability. It is used to describe how likely or unlikely something will happen. Probability may be given in fraction, decimal, or percent. The value of probability ranged from 0 to 1. 0 means the event is impossible to happen, while 1 means the event is certain to happen. The event is unlikely to happen when its probability is closer to 0, like winning a jackpot in a lottery where you only have 1 in a million chance of winning. The event that is most likely to happen is closer to 1. Let's study example number 1. There are colored small cubes inside a box. There are 4 blue, 2 yellow, 3 red, and 1 green small cubes. What is the likelihood of picking a yellow cube out of the box? If you add 4 blue plus 2 yellow plus 3 red and 1 green, the total is 10. Since there are 10 colored cubes inside the box and there are 2 yellow, the chance of picking yellow cube is 2 out of 10, or in lowest term, it is 1 over 5 or 1/5 or 20%. So, it is unlikely to pick yellow out of the box. When we use a formula to find the probability of an event, we are finding the theoretical probability. Theoretical probability of an event is the number of ways that an event can occur divided by the total number of outcomes. The formula in finding theoretical probability is theoretical probability equals number of favorable outcomes over number of possible outcomes. In our example, the number of favorable outcomes is 2 since there are 2 yellow cubes, and the number of possible outcomes is 10 since there are total of 10 cubes inside the box. So 2 out of 10 or 1 out of 5 or 1/5. Therefore, the theoretical probability of getting yellow cube is 1 over 5. We can also find the probability of an event by doing an experiment. When we do this, we are finding experimental probability. Experimental probability of an event is the ratio of the number of times an event occurred to the total number of trials or times the activity is performed. The formula in finding experimental probability is experimental probability equals number of times favorable outcomes occur over number of trials in the experiment. Let us use the given example 1 in an experimental probability. Number 1. Take a cube inside the box. Number 2. Record the color and return the cube in the box. Number 3. Repeat the process at least 10 times. And number 4. Count the number of times a yellow cube was picked. Suppose it is 4, using the formula we have. So let's find the experimental probability. Experimental probability equals 4 out of 10. Or in lowest term, it is 2 out of 5. Because if we divide 4 by 2, 4 divided by 2 equals 2. And 10 divided by 2 equals 5. The experimental probability is 2 out of 5. Example number 2. In a die, what is the probability of getting a face with 1 dot, 3 dots, and 5 dots? A die has 6 faces, with dots numbered 1 to 6. Each number is equally likely to occur. Let's find the theoretical probability. So theoretical probability or getting a face with 1 dot equals 1, which is the number of favorable outcomes, and the number of possible outcomes is 6, 1 out of 6. Now, the theoretical probability of getting a face with 3 dots is 1 out of 6. And the theoretical probability of getting a face with 5 dots is 1 out of 6. Now, let's study example number 3. Arkin is tossing a coin. He tossed the coin 50 times. It landed on tails 38 times. Find the probability of landing on heads. Since tails landed 38 times, therefore, heads landed 12 times. Because he tossed the coin 50 times. 50 minus 38 equals 12. Let's find the experimental probability. The number of times favorable outcomes occur is 12. And the number of trials in the experiment is 50. So 12 out of 50. Or, in lowest term, it is 6 out of 25. Example number 4. A medical study tested new vaccine on 4,800 participants. It is effective to 4,200 participants. Find the experimental probability of the effectiveness of the vaccine. The number of times favorable outcomes occur is 4,200, and the number of trials in the experiment is 4,800. So this is 4,200 out of 4,800. In lowest term, it is 7 out of 8. Or, in percent, it is 87.5%. The experimental probability that the vaccine is effective is 7 out of 8, or 87.5%. Theoretical probability is what we expect to happen, while experimental probability is what actually happens when we try it out. As more trials conducted, the more experimental probability generally gets closer to the theoretical probability. Now, let's do learning task 1. Tell whether the given situation is an experimental or theoretical probability. Number 1. Probability of getting a dot when rolling a die. Is it experimental or theoretical probability? Very good! The correct answer is theoretical probability. Number 2. Tossing a coin 50 times, it landed head 22 times. What is the probability of landing a tail? Is it theoretical or experimental probability? Very good. The correct answer is experimental probability. Number 3. Chances of winning a raffle contest. Is it theoretical probability or experimental probability? Very good. The correct answer is theoretical probability. Number 4. A day chosen from a week. Is it theoretical probability or experimental probability? Very good. The correct answer is theoretical probability. And number 5, a survey was conducted about efficacy of video lesson. 200 grade 6 pupils were the participants. 145 students said it is effective and big help in modular distance learning. Is it theoretical or experimental probability? Very good. The correct answer is experimental probability. For learning task 2, solve the following problems. Make prediction based on the problem. Letter A. A spinner is divided into 4 equal sections, numbered 1 to 4. It is spun 100 times. Here are the results of the spin. Number 1 is 28 times. Number 2, 35 times. Number 3, 25 times. And number 4, 12 times. Number 1, find the probability of that 4 will be spun. So the probability is 12 out of 100. It is spun 12 times out of 100 times. Or, in lowest term, it is 3 out of 25. Number 2, find the probability of that tree will be spun. And here is the answer. 25 out of 100 or 1 out of 4. Number 3, find the probability of that 2 will be spun. And here is the answer. 35 out of 100 or 7 out of 20. And number 4, find the probability of that 1 will be spun. And here is the answer. 28 out of 100 or 7 out of 25. Letter B. A drawer contains 6 black marbles, 2 white marbles, 4 red marbles, 2 maroon marbles, and 2 blue marbles. 1 marble is picked at random and then replaced. Predict how many times can you expect the color of the marble to be picked. Let's start with letter A, white. There are 2 white marbles. So the probability is 2 out of 16. How do we get 16? Because if we add 6 black plus 2 white plus 4 red plus 2 maroon plus 2 blue equals 16. So the answer is, white is 2 out of 16 or in lowest term it is 1 over 8. Letter B, blue. There are 2 blue marbles out of 16 and the lowest term is 1 over 8. Letter C, red. There are 4 red marbles out of 16. 4 out of 16 or in lowest term it is 1 over 4. Letter D, black. There are 6 black out of 16. 6 out of 16, in lowest term it is 3 out of 8. Letter E, maroon. There are 2 maroon out of 16 or in lowest term it is 1 over 8. And letter F, not white. 16 minus 2 white equals 14. So there are 14 out of 16 or in lowest term it is 7 out of 8. For learning task 3, from a deck of cards, you draw 1 card at random. Find the probability of drawing each of the following. A standard deck of cards has 52 cards, divided as follows. 26 red cards, which are 13 hearts plus 13 diamonds, equals 26. 26 black cards, which are 13 spades plus 13 clubs. So 26 plus 26 equals 52. In the deck of cards, there are 4 aces and 1 king of hearts. So let's answer. Number 1, a red card. There are 26 out of 52 cards, or 1 out of 2. Number 2, a black card. There are 26 black cards out of 52 cards, or 1 out of 2. Number 3, an ace. So there are 4 aces out of 52 cards, or 1 out of 13. Number 4, a spade. There are 13 spades out of 52 cards, or 1 out of 4. And number 5, a king of hearts. There is 1 king of hearts out of 52 cards. For learning task 4, 2 coins are tossed at the same time for 20 times. Below are the results of the tossing of coins. Based on the problem above, answer the following questions. What is the experimental probability that the result is 2 heads? Let's count the 2 heads in the table. 1, 2, 3, 4, 5, 6. So that means the number of 2 heads are 6 and the total outcomes is 20. 6 out of 20. How do we get the total outcomes 20? If we add the toss according to the table, the result is 20 toss. So that is 6 out of 20 or 2 out of 10. Number 2. What is the experimental probability that the result is 2 tails? Let's count the 2 tails. 1, 2, 3. The number of 2 tails are 3 out of 20. And for number 3, what is the experimental probability that the result is a head and a tail or vice versa? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So therefore, the number of head and tail or tail and head are 11 out of 20. And for the last activity, assessment, solve the following problems. Write the correct letter of the correct answer in your notebook. Number 1. Each of 11 letters of the word mathematics is written in a separate card. The cards are placed face down and shuffled. A card is chosen at random. What is the probability that it will show the letter M? A. 1 out of 11. B. 2 out of 11. C. 3 out of 11. D. 4 out of 11. Very good. The correct answer is letter B, 2 out of 11, because there are only 2 M in the word mathematics. Number 2. There are 6 red balls and 4 blue balls in a jar. What is the probability of picking a black ball? A. 1 out of 10. B. 4 out of 10. C. 6 out of 10. And D. 0. What is the correct answer? Very good. The correct answer is 0. There is no black ball. Number 3. There are 2 empty seats next to each other on a bus. 2 boys and 2 girls get on the bus. What is the probability that 2 boys will sit the empty seats? A. 1 out of 4. B. 2 out of 4. C. 1 out of 3. D. 0. Very good. The correct answer is 2 out of 4. Number 4. A survey was conducted about efficacy of video lesson. 200 grade 6 pupils were the participants. 145 students said it is effective and big help in modular distance learning. Find the probability of efficacy of video lesson. A. 29 out of 40. B. 28 out of 40. C. 27 out of 40. D. 26 out of 40. What is the correct answer? Very good. The correct answer is 29 out of 40. And for number 5, tossing a coin 50 times. It landed head 22 times. What is the probability of landing a tail? A. 14 out of 25. B. 13 out of 25. C. 12 out of 25. D. 11 out of 25. What is the correct answer? Very good. The correct answer is 14 out of 25. So kids, do you understand our lesson for today? Wow! Good job! Kids, I hope you learn a lot from this lesson. Until our next topic, bye-bye kids! Thanks for watching!